All right, so 7.3 we're dealing with factoring. And really another word for factoring, we just learned how to multiply polynomials. And really another word for factoring, you're doing this when you use regular numbers too, is you're really dividing. That's what you're finding. What are the two things I can get? I can multiply together to get that polynomial. Okay. So first thing we're going to have is something called zero product property, which you've actually been dealing with for a really long time. You've just never called it zero product property. So all it says is if I'm multiplying two numbers together, and when their product is 0, then one of those numbers has to be a 0. So let's leave polynomials out of it for a minute. If I'm going to multiply 3 times some number and get 0 as an answer, then that number has to be 0, right? So let's say we call it x. Then x has to be 0. So one of these two numbers has to be 0 in order for the product to be 0. That's all that it's saying. So if we've factored a polynomial, say we've gotten this one, and we're going to deal with factoring in a minute, then what this means is I need to make one of these equal to 0 if my product is going to be 0. If I have two binomials and they're being multiplied together, then one of those has to equal 0 if my product is 0. Okay? So what you're really doing is saying, okay, well, if I need to get this x minus 6 to equal 0, what number do I have to put here for x that would make this equation equal 0? So one way to do it is to set it equal to 0 and solve. Right? So that would be 6. And if I check that, 6 minus 6 equals 0. That's right. But I have another option. So if I multiply 0 times x plus 5, 0 times anything is going to give me 0. That's going to be okay. Okay, but my other option is what if I just leave x minus 6 alone and I make this parentheses equal to 0? Okay, same thing. What number do I have to put in there to offset this positive 5? The other thing you can ask yourself is what is the opposite of that positive 5? Because whatever I did here, I added 5. I have to do the opposite to get it to equal 0. So let's check that. So negative 5 plus 5 equals 0. That's fine. And if I have x minus 6, now I've got a 0 here, that's definitely going to give me a product of 0. So I'm okay there. So my two solutions are going to be x equals negative 5 and x equals 6. Okay? Even works when we've got coefficients going on, when we have fractions going on, it's all fine. So you're going to take each of your factors separately and set them equal to 0. So really you're just solving two little baby equations. So the opposite of negative 3/4 would be positive 3/4. 3/4 minus 3/4 would be 0, so that's okay. And then here I need to subtract 5. So I would get 4b equals negative 5. And then dividing by 4, my b value would be negative 5/4. Okay? Now let's just show you something real quick. Let's go back to this one because it doesn't have any fractions, or it's kind of straightforward. Since you're a pro at multiplying polynomials, I want you to go over here in the margin and multiply x minus 6 times x plus 5 together. Okay? I'm going to use box method to do that. So I have x minus 6, scooch him over, x minus 6 and x plus 5. And when I multiply that, I get x squared, negative 6x, 5x, and negative 30. I know I have to add those two terms together. So I get x squared minus x minus 30. Okay. So in the last unit we talked about finding the zeros, and we did a couple things. We used square root method, we used quadratic formula method to find the zeros of something like this. And that told us where it sits on the x-axis. So let's see what happens when I plug in one of these numbers here. I should get this to equal 0. Let's see if I do. So the first one is I'm going to sub in positive 6. So that gives me 6 squared minus 6 minus 30. And the goal is that I'm going to get 0 as an answer. So that's 36 minus 6 minus 30. Well, 36 minus 6 is 30, minus 30 equals 0. That's definitely true. Let's try it again for negative 5. So I have negative 5 squared minus negative 5 minus 30. So that would give me 25. Negative negative is a positive, minus 30, and 30 minus 30 equals 0. So that again checks out. So I want you to think about maybe why we would solve by factoring, especially if something is factorable. Not all quadratic equations you see are going to be factorable. Many of them are, especially the ones that we're going to use here in Integrated Math 1. So this is a really easy way to find those 2 points that sit on your x-axis. A really easy way. So it's one of the main reasons you're going to use that. Okay, so let's move on to factoring out a greatest common factor. So that's a phrase you've seen before, greatest common factor. I want you to just think about what that means. So it just means a number or variable that is in all the terms. Okay? So think about greatest common factor. If I asked you all for $5, which I'm not going to do, but if I did, all of you would have to have $5 in order to be able to give it to me. If any of you don't, then it's not a common factor because you don't all have it in common. You don't all have $5 in common. You might have a 3 in common, you might have $1, you might have 50 cents, you might be dead broke. But in order for me to take a common amount away from all of you, you all have to possess that amount. So I want you to think about what numbers can go into 15 and 20. And one way you can do this, you're going to look at your coefficients and your variables. So I know that 15 is made up of 3 and 5 and x. I'm just changing this term. Plus 20 is made up of 4 and 5, and then it's being multiplied by y. So the only thing that I have in common to both of those is a 5. So that is what's going to come outside the parentheses. And then what I have left in this first term is a 3x plus I have a 4y. Okay? The way that you double check factoring is you multiply it back, right? Easy way to double check anything is do the reverse of what you did to solve it. So 5 times 3x is 15x, and 5 times 4y is 20y. The other way you can think of it, since we know that factoring does mean divide, is you're just dividing these each by 5. Now, the only thing I caution you is to make sure that you write the 5 out in front of the parentheses. 5 goes into 15 3 times. I have a 3x left there. And 5 goes into 24 times, and I have a 4y there. Okay? So, same thing with variables. And you have, let's think about what we have here. So we've got, well, I know that 12 is 3 times 4, and I have 2 y's there, minus a 3 times a 7 and a y. So in this case, I actually have a couple things in common. I've got a 3 in common, and I have 1 y in common. So that 3y is going to come out, and then I'm just going to add back whatever I have left, minus the 7. And if I double check that, 3 times 4 is 12, y times y is y squared, 3 times negative 7 is negative 21, and I've got the y there. Okay? It's kind of backwards distributive property, really. Okay, so now we're going to solve by factoring. And these are just monomials. We're going to get into, these are binomials. We're going to get into trinomials here pretty quick. So I want you to just ignore that 0 for a minute and apply what you just did right above. So let's think about what we can take out of a 10 and a 15. Well, we can take out a 5, and then of x squared and x, they both have 1 x in common. And then in my parentheses, I'm still going to leave that 0 off there. I'm just going to divide this out. So if I have 10 divided by 5, I've got a 2. And then I had 2 x's, I took 1 away. I have 1 left. Negative 15 divided by 5. Negative 15 divided by 5 is negative 3, and x divided by x is just 1, so we're just going to leave it like that. And then we're going to set that equal to 0. And remember what zero product property told us. Product property. So we just set each factor equal to 0 and solve. So I'm going to have, this is one term, right? This is one term, this is another term. So I got 5x equals 0 and 2x minus 3 equals 0. So here I'm going to divide both sides by 5. So one of my solutions is 0. Here's a little hint for you. If there's no addition or subtraction going on, you have a monomial, that solution is always going to be 0. Because the only thing that you can put in there to solve, to get a product of 0 is going to be 0. So that's a little hint you want to kind of put in the memory banks. Here we're going to have 2x equals 3, and then divide both sides by 2. So my other solution is going to be 3/2. Here's another good thing to talk about. These are your factors. These are your solutions. Definitely related to one another, but certainly not the same thing. Okay? Anytime you have a solution, you have letter equals a number. Here, you've got them separated out, but we haven't solved yet. So I need you to really understand the difference between those two things. Okay, we know from our quadratics unit that our quadratic equations always have to be set equal to what before we solve? They need to be set equal to 0. So this has got to travel back to the other side, and when it does that, it's going to flip its signs. So now on the right side we have a 0, and on the left side we have 6w squared minus 12w. Remember, you're not putting those together because they're different terms. These are double doubles, these are singles. Different burgers, different prices, different sizes. They can't be put together, right? Okay, so now let's look and see what you have here. So I'm going to factor this a different way so you can see what you've got here. So I know I can take a 6 out of both of these, and I have a w that I can take out of both of these. So 6 divided by 6 is just 1. I have more w's on the top by 1. 6w is my common factor that I'm taking out. Negative 12 divided by 6 is negative 2, and w divided by w is just 1. Now I can set that equal to 0, and now I can solve for each of my terms. So I'm going to set 6w equal to 0, and w minus 2 equal to 0. The only thing I can plug in here for for w to get 0 is 0. If you need to go through the steps to get that, it's perfectly okay. Okay? The more you do this, at some point it's just going to click. Maybe it already has. That would be awesome. Okay? So our solutions are 0 and 2. Remember that in quadratic equations you will always have two solutions. Okay? Good. Okay, I've got a couple for you, one to factor and one to solve. So go ahead and hit pause, try that on your own, and then come back and check to see what I've done. Okay, looking at my factors, I know I can take out I like to have this first one always be positive. So if I've got a negative coefficient there, I'm going to take the negative out. So I can take negative 2 out of negative 2, 14, and 6. So I'm going to take out a negative 2, and then I've got 4 g's here, 2 g's here, and 1 g here. So the most I can take out of all of them is just the 1. So negative 2 divided by negative 2 is just 1. G to the 4th divided by g is g to the 3rd. 14 divided by negative 2 is negative 7. And g squared divided by g is just g. 6 divided by negative 2 is negative 3. And g divided by g is just 1. Okay, if you did it division method, you could have had negative 2g to the 4th plus 14g squared plus 6g. If you only factored out a 2 out of everything instead of a negative 2, that would have been okay too. Your signs would be different. You would have you would have 2g on the outside, and you would have negative g to the 3rd plus 7g plus 3. So I want you to recognize these are equivalent expressions there. This is exactly what this is, just with all of the signs flipped. Okay? Good. All right, solving, I need to move that 15y to the other side, and when I do that, it changes its sign. I know I can take a 3 out of 9 and 15, and I can take a y out of y squared and y. So I'm going to take a 3 out of both. 9 divided by 3 is 3. Y squared divided by y is y. Negative 15 divided by 3 is negative 5. And y divided by y is just 1. Then I set all that equal to 0. Set each term equal to 0. So my y is going to equal 0 there. And then 3y would equal 5. That travels and changes signs. Divide both sides by 3. And y equals 5/3. I'm going to do lots of practice. See you in class.